Okay guys, so now let's move to the next question. But before we do, as you can see on the screen of my tablet, we're given a mini statement there, and it reads as follows. At the same instant that stone A is projected upwards, stone B is thrown vertically downwards from the same height at an unknown speed, being V. Refer to the diagram below. So, as you can see, this is the diagram. I've already explained it in the previous lesson. We are solving for question 3.1. So let's not spend additional time on re-explaining that given diagram. So we can now move to the next statement. As you can see there, it says when stone A reaches its maximum height, the speed of the stone B is 3v. Okay, so I will just try to simplify that statement, and again I might need to just redraw that diagram because I've just noticed from the feedback that I get from the students that we do live lessons that they understand it better when I redraw that original diagram. So the one that I redraw, that's where I put in additional information so that it doesn't confuse when we move to the next questions. So let me just do that level there, and remember this is A, and then we've got the ground. Everything it's at a certain unknown height. So now what that statement that I've just read says, it actually says at the same time when this object A is being projected vertically upwards, stone B it's being projected or thrown vertically downwards at an unknown speed, which is V. Okay, so remember guys, there are two ways in which an object can be moving downwards. It's either you drop it or you throw it downwards. So in this instance, they say at the same instant that stone A, which is that one, is projected vertically upwards, stone B, which is that one, is thrown vertically downwards from the same height. So it means A and B are on the same height. Okay, and this is thrown vertically downwards at an unknown speed, which is being called V. Okay, so I assume you understand that part. So they say when stone A reaches its maximum height, the speed of stone B is 3v. Remember guys, from the previous question I've just indicated that this object is thrown vertically upwards, is going to reach a certain height, and it takes a certain time for it to reach that maximum height, and we've just calculated time to be 1.22 seconds from the previous question. So that means after 1.22 seconds, the speed of this object B, which is thrown vertically downwards, will be 3v. Okay, so I think it makes sense guys, because when I explain these things, at the same time I'm trying to think about them, and at the same time I'm trying to think if I'm giving the simplest explanation that you can easily understand. So I assume you do understand. I'll just quickly try to re-explain that scenario. So remember, this object A is being projected vertically upwards, so that means it's going to go up and reach a certain height, and its velocity there, it will be 0. So it takes 1.22 seconds for this object to reach its maximum height, where its v final is equals to 0 meters per second. So they are saying, as this object travels until it reaches its maximum height, this object, which was thrown vertically downwards at the same time when this object A was projected vertically upwards, when it reaches that maximum height, the velocity of this object will be 3v. I hope it makes sense. So now let's check what the question says. I hope you can see. So the question says, calculate the speed, which is v, with which the stone B is thrown vertically downwards. So you can see, guys, they are saying calculate v. So in this case, our v obviously refers to that v which is v initial, because obviously this object is thrown vertically downwards at a certain initial velocity, and after some time, which is this time, after 1.22 seconds, its velocity, they've just indicated that it's 3v. Okay, so we are now at that stage where we need to look for the relevant formula. So we go to our formula sheet, and then from there, that's when we're going to decide on which formula to use. So I normally start from that first formula to check if I can use that formula. If it can't apply, I move to the next formula. I will check that formula. If it doesn't apply, then I check that formula. If it's not applicable, then I check that formula. So remember, guys, I've just indicated there are multiple ways in which these questions can be solved, but I'm only interested in showing you the simplest way of solving these questions. So let's check. Have we got final velocity? It seems like we do. Have we got initial velocity? We do. The acceleration, it remains the same. In this case, it's gravitational acceleration. So it seems like even for this question, we'll be using the same formula, which is v final, it's equals to v initial plus g, a change in time. So in this case, guys, we can decide on the directions. So since this object is going down, and we know that our g, it's always going down, then we can just assume a down to be positive, just to make things simple. So that means a positive down, meaning anything going up will be a negative. So positive down, up, negative. So let's see. Our v final, it's going to be a 3v. Why are we saying our v final is going to be 3v? It's because we know when the v or the velocity final is 3v, that's when the time is 1.22 seconds. So that means we're going to use that time, this final v, which is 3 times than the initial v, and then we obviously know g. So we're going to substitute everything in terms of v and calculate v. So the v that we get is the initial velocity, meaning is the velocity at which object B is being thrown vertically downwards. So remember, guys, our v going down is positive. So we've got positive 3v in brackets. It's equals to v, which is plus, we know our g, remember it's positive because it's going down, and then we know our time is 1.22. So in terms of time, there's no a positive or negative sign because time is a scalar quantity. So you know with the scalar quantity, you only have a magnitude. And if we're dealing with vector quantities, that's where you have a magnitude and a sign. So in physical sciences, a sign refers to the direction. So a vector quantity, that's where we talk about the the magnitude or the value and the direction. So now we can move this to the other side. We know it's going to be 3v minus v, which is going to be 2v. It's equals to multiply this 2. Let's see what we get. 9.8 multiplied by 1.22. We get a fraction to decimal. It's 11.956. Then at this stage, you can just divide by 2. You also divide by 2 so that it cancels and you remain with v. V, it's equals to that answer that we got. I just divided by 2. Then it means you've got 5.978. 5.978, of which I can just round it to 2 decimal places. It's a 5.98 meters per second. Obviously, because our answer was positive, then it means this object was moving downwards. So this is the final answer to this question. So now the marking part, remember guys, this question is allocated 4 marks. Okay, so in terms of marking, I'm going to give you a mark for choosing the correct formula, and I think you deserve 2 marks for correct substitution there, guys, because for you to substitute correctly in that way, it means you applied your mind and you understood exactly what the question wanted you to calculate. So the final mark I'm going to give you on your final answer, the correct final answer. And when I say the correct final answer, I'm talking about the value and the correct SI unit. So this is how you solve for question 3.2, guys. I don't think also this question was that much difficult. So now, without any waste of time, I think we should move to question 3.3. Remember guys, if you are new to our channel, welcome, and thanks for choosing our channel to use for your studies. And please remember to hit the subscribe button and the notification bell so that you are notified of our daily uploads. Otherwise, my name is Desmond and I'm out.